Hello, in this presentation I like to show you the flexibility of our USB measurement microphone ESV1611. The standard microphone capsule is class 1 according to the WS2F class 1 standard. So W2S means working standard, 2 for half-inch capsule and F for free field capabilities. So means with this microphone capsule we can measure from 4 Hz up to 20 kHz. If I remove the capsule and select another capsule with other properties, so this is here the MK222. This capsule can measure from 0.5 Hz up to 20 kHz. So in this combination with the USB microphone preamplifier, we can measure in this case from 1 Hz up to 20 kHz. So for this presentation I like to show you how to measure ultrasound frequencies. So in this case I have here a half-inch adapter to quarter-inch adapter, and here we have a quarter-inch capsule MK301E, so which can measure from 5 Hz up to 100 kHz. With 192 kHz maximum sampling frequency of the preamplifier, we can measure to about 80 kHz. So for this reason, in this combination, we have now an ultrasound USB measurement microphone with the capability to measure up to 80 kHz. So this is now the ultrasound USB measurement microphone. Now for this presentation I like to show you the ARTA software, which is meanwhile freeware. So it is now here, and as first I like to show you how to calibrate in the ARTA software the microphone. So for this I can go here to the calibration menu. So let's assume that the signal is now coming. So it must be 94 dB, means 1 Pascal. So now. So now in this combination we can see that the sensor sensitivity is 1.6 millivolt per Pascal. So if I remove now this capsule with the adapter and put the infrasound capsule on it, so we should see that the sensor sensitivity with this capsule is now 42 millivolt per Pascal. So because it's half-inch, it is more sensitive. So with this ultrasound capsule, because the sensor sensitivity is relatively unsensitive, we can measure also high sound pressure levels beside the ultrasound capabilities. So, I remove it now. So now let's measure. Now let's measure here the environmental noise. We have here the FFT analyzer with 192 kilohertz. And now without averaging. So, of course, we can change here the FFT line resolution, the FFT windowing, and so on. The typical properties of a standard FFT analyzer. Now, I like to see what kind of ultrasound we have here in this office. So now I change here to linear averaging. And we can see here at about 44 kilohertz. Here at about 44 kilohertz we see here a peak with 74 dB sound pressure level. So it is relatively high, but it's ultrasound, so we can't hear it. So now one another tool is here the integrating sound pressure level meter. So sound level meter. We have here the typical properties of a sound level meter. If we want, we can log the calculated LEQs, A-weighted, fast, filtered, and so on and so on. So as first, to make sure that everything is fine, I cross-check the calibration. So my calibrator delivers 94 dB. I take the left channel of the USB microphone and let's check. So we can see that here the level is changing very strong. So let's measure again. So now it's constant. So this is now the estimated sensor sensitivity. We will accept it. Okay. Now let's switch to fast mode, A-weighted. So here we have the typical filters, let's say set. We can record the data. Here we see the 94 dB value. So and now we can measure here the environmental noise of this office. So after the measurement, it is possible to export this results in CSV format. So I export this ESV 1611 MK301E capsule here to the desktop. So now let's close this. And here we have now our results. So we can see here, that's correct, that with a timestamp we have here the sound pressure level of 93, well, close to 94 dB. So, and then here's the environmental noise. So one important hint, in the Windows sound settings, it is necessary before you make the measurements, make sure that in the sound settings the recording device ESV 1611 have this signal enhancement checkbox disabled. So this is very important, otherwise Windows will manipulate somehow the sound and this will be not calibrated. So that's all for today, and I wish you a pleasant day, and again, thank you for your attention. Goodbye.